Hi everyone, so here we're going to find the domain of some logarithmic functions. Let's start with the first one. You have f of x equals ln of x plus 4. First of all, a quick reminder about logarithmic functions domains. When you see any logarithmic function with any base b, including the ln, including the decimal log, including any logarithmic function, you have to check that what's in the brackets here is greater than 0. And this allows you to determine the domain of your functions, okay? So here we have ln of x plus 4. We have to check that x plus 4 is greater than 0, which means that x is greater than negative 4, and it gives us our domain. So the domain of our function is the set of numbers, of real numbers, which are greater than negative 4, which gives the open interval negative 4, infinity. So this is the domain of your function f. We will move to the second one, log of x squared plus 1. So here we have g of x equals log of x squared plus 1. Again, here we have to check that what's inside the brackets is greater than 0, because the argument of the log is always positive. So let's check that x squared plus 1 greater than 0, which means that x squared is greater than negative 1, but this is always true. It means for any real number, x squared is positive, so it's greater than negative 1. So this is always true. And since it's always true, our domain is the set of all real numbers, okay? So the domain here is the set of all real numbers. It means R. Let's move to the third one, which is the most difficult one. H of x equals 1 over log 7 of x plus 1. I will write it here. So h of x is equal to 1 over log 7 of x plus 1. Here we have two conditions to check. The first one is the log domain. It means what's between the brackets of the log is greater than 0. Its second condition you have to check is that the denominator here is not equal to 0. So let's start with the first condition. X plus 1 greater than 0, which means that x greater than negative 1. This gives us the set of all numbers, all real numbers, which are greater than negative 1. It means the open interval negative 1, infinity. The second condition is log 7 of x plus 1 not equal to 0. You have to know that the only input which gives 0 for logarithmic functions is the number 1. So this quantity must be not equal to 1, because if you plug in here 1, you will find 0. So the solution of log 7 of x plus 1 not equal to 0 is x plus 1 not equal to 1. And it gives x not equal to 0. So you have two conditions here. The first one is x greater than negative 1 and x not equal to 0. And both must be satisfied. So the domain will be the intersection of these two conditions. So let's first draw our first condition, which is x greater than negative 1, x greater than negative 1. So we have to exclude the negative 1. Let's say it's here. Okay? So it's the set of all numbers which are greater than negative 1. From negative 1 to infinity. I'm making this illustration to explain the intersection of the two conditions. And then x not equal to 0, but the 0 is some around here, okay? So you have a first interval combined with a second interval. Okay? So the domain here will be the set of all real numbers starting from -1, not included, to infinity except 0. So you can write your domain as domain is the union of the two intervals, -1, 0, and the interval 0, infinity. Of course, you can write it differently. You can write it as the interval -1, infinity, and you exclude the point 0. Okay? So be careful. I will repeat here that the input of any log function must be not equal to 0. And be careful when you have a log in the denominator of a rational or a fraction. Be careful, you have to check that it's not equal to 0. Okay? And especially here, we use the fact that the only input which gives 0 for the log is the number 1. So if you have log 7 of x plus 1 not equal to 0, the input here must be not equal to 1. Thank you for your attention and see you in the next videos.